Okay, you guys, so we're going to cover 10.3, solving linear systems of equations. So this will feel very similar to something you did in a previous math class where you had to solve a system of equations with lines, or a linear system of equations. So, in the past, you would have, a graph, and you would have a line that goes this way, and then you would have like a line that goes that way, right? And this is some y equals, mx plus b, and this is some y equals mx plus b. Okay. And then you would find that the system had a solution right here. Okay. The intersection of this. So the difference we're going to do now is when we go into nonlinear systems, whether it's by elimination or substitution method, we're going to have something like, say, this. We're going to have a parabola, let's say, and then we're going to have a line go through it. So then this, So this is obviously linear, but the parabola is not linear. So this is what they mean by nonlinear systems of equations. And you notice now there's two intersection points, whatever that is and whatever that is. So we'll have multiple answers for certain problems, okay? But now that we know how to do, we could do a parabola like this, and then we could have another parabola like this, and then these would now become the intersection points. So we could also have circles, hyperbolas, parabolas. So now they're saying that all these conic sections, we can now use these to find more than just the one intersection point when you're dealing with two lines, okay? So a nonlinear system of equations is a system of equations where at least one of the equations is not linear. And that's what I did. One of them was linear and one of them wasn't, or there's a case where it could be multiple nonlinear. So if I'm asked to solve this equation, so if I'm asked to solve this system, the first method I'd like to use is, we're going to use substitution on this first one, but we could also use elimination, but sometimes just depending on the problem, something looks a little bit nicer than others. In this particular problem, remember in previous cases, if you had, y equals 2x plus 3, and you had y equals 7x minus 4, and this was your system, what you could do is you could take and put 7x minus 4 in place of y. Okay, so you take one equation and you substitute it into the other one. So we're going to use similar thinking to that for this particular problem. Okay, but now instead of being two lines, we see that this is obviously a parabola, and then this is obviously a line, right? Because it's a parabola, because the x is squared. We know, in fact, it's a downward facing parabola that is shifted up 4. And I can tell that just because if I subtracted the x squared over, this would be negative x squared plus 4. So if I were to draw this, I could see that I would go up 4, 1, 2, 3, 4, and I would draw a downward parabola, like something like that. And I could find the x-intercepts and the y-intercepts and all that if I wanted, but they didn't ask me for all that, so I'm just going to do this, okay? Now we know that the line y plus 2 equals x. This is actually y equals x minus 2, because I could just subtract the 2 over. So if I wanted to draw this line, I would go down negative 2, 1, 2, put a point, and then, rise over run. I would rise 1 and I would run 1, right? So then we have this line. So it appears there's an intersection here. But remember, with parabolas and with parabolas and lines, they go on forever, right? So there's another intersection that happens way down here somewhere that I didn't draw, right? And then the line goes through here. So there's another intersection right there. So we're pretty sure there's going to be two intersections with this particular solution. So let's just see what happens when we do our little substitution method. So I'm going to use substitution, and it says that y plus 2 is equal to an x. So that means everywhere I see an x, I can put y plus 2. So I'm going to see an x right here. So I'm going to take y plus 2. I'm going to take y plus 2, and I'm going to put it right there for x. And again, you could choose other ways to do substitution. This is just the one that looks quickest to me. So this is going to become y plus 2 squared, because remember, the x is being squared, plus y equals 4. So I took one equation and I substituted it into the other. Now, when I FOIL this out, this will become y squared plus 4y plus 4 plus y equals 4. Now, when you have squareds, your job is to get everything on one side and set it equal to 0 in general. So I'm going to subtract 4 from both sides. So this will become y squared, combine like terms, plus 5y. And then it looks like that will equal 0 because the 4's will cancel. Okay. So now I know that I can change this to y times y plus 5 by factoring out a y. And then over here, I'm going to set y equal to 0, and I'm going to set y plus 5 equal to 0. Okay, so now let's solve this real quick. So we have y equals -5. So y equals 0 and y equals -5 is our two solutions. Okay. However, when you're solving a system, normally you want to know the x and the y values. So all we have done is find the y values. So we now have to find the x values. Well, it looks like y plus 2 equals x will be the nicest one. So I'm going to plug 0 into this. So y equals 0. And I'm also going to do y equals 0. Oops, y equals -5. I'll do this guy right here. Y plus 2 equals x. And I'll do y plus 2 equals x for this one. So when I plug 0 in for y, I get 0 plus 2 equals x. So x equals 2, right? And then I get -5 plus 2 equals x. So x equals -3. Okay, so here's my x values, here's my y values. So what this means is these 2 points over here, these 2 points, this point, so we have the point 2, 0, and we also have the other intersection point of -3, -5. So this would be -3, -5 right here, and this point would be 2, 0. So that's how you can solve a system by substitution. Sometimes substitution is better, sometimes elimination is better. In general, I feel like they both should work most of the time, but there's normally one that's better than the other. Okay. All right. So, and as you can see, they have a little bit better drawing than I do right here. But it shows you just what we did right now. And again, it really helped that I knew how to draw a parabola that was downward facing really quick. And it really helped that I knew how to do a line. I didn't have to use my calculator for it. I just kind of knew how to do it based on what I've learned in previous classes and how lines work and everything like that. Now, in this particular problem, we have x squared plus 2y squared equals 4. And we have x squared minus y squared equals 4. So this looks like we're dealing with possibly, remember, you want it equal to 1 when you're dealing with an ellipse or a hyperbola. The plus sign normally tells me it's an ellipse. The minus sign normally tells me it's a hyperbola. So this becomes x squared over 4 plus 2y squared over 4 equals 1. So that's definitely, when I cancel that and that, this is definitely an ellipse. And then this one, when I divide by 4, this would be x squared over 4 minus y squared over 4 equals 1. That would be a hyperbola. Okay. Now, again, most of what we did, these would be, pretty straightforward hyperbolas, but we know there's a lot that can happen now. We know that this could be a hyperbola that looks like that. And then there could be, an ellipse that looks like this, or something like that. So there's a potential to be 4 intersection points, depending on how it works out. I mean, it could also just as easily be something like this, right? It could be a hyperbola that goes like this and this, and then we could have our ellipse, be the inside part and only touch one time on each side. So we could have 4 intersections. We could have 2 intersections. We could even have no intersections, like if the ellipse doesn't touch the hyperbola, So there's a lot of situations that can happen. So we're going to try to solve this. Now, for me personally, you could absolutely do elimination, or you could absolutely do substitution. Let me see how many I have left. Okay, so for this one, I think I'm going to use, because the powers are all the same, I think I'm going to use elimination. Okay, so what the elimination method says, so let me write it over here. So we have x squared plus 2y squared equals 4. And we have x squared minus y squared equals 4. Okay, so what the elimination method does is it adds the 2 equations together and one of the variables eliminates. So in this case, if I multiplied the top equation or the bottom equation by -1, I would get this. I would now have negative x squared, minus 2y squared equals negative 4. And then the bottom equation stays the same. If I now add these, we notice that the x squared and the y squared go away. They cancel, right? They eliminate. And we're now left with negative 3y squared equals 0. Okay, so then that means then that y equals 0, right? Because the only way for negative 3y squared to be 0 is y has to be 0. Okay, so now that's our only answer. Okay, there's no two choices about it. That's got to be the answer. Okay, the problem is what comes next. Now we have to solve for x. So when I do x squared minus y squared equals 4, and again, you might say, well, you know, how did you choose to use the bottom equation versus the top equation? It's whichever one looks easier to work with, because it's a system. It should work in both, right? That's the whole point. So what I'm going to do is I'm going to take the y equals 0 and I'm going to plug it in here. Okay, so now we have, you know what, let me write this over here. I'm going to run out of room. So now I'm going to do the y equals 0, and I'm going to use x squared minus y squared equals 4. Okay, so when we do that, we plug 0 in, we get x squared minus 0 equals 4. We have to square root both sides to solve for x, and we now get x equals plus or minus 2. So that means that there are two x values associated with one y value. So we have 2, 0, and we also have the point negative 2, 0. So there's not 4 intersections. So this is not the situation that happened, right? It's more like this. This situation happened where this is negative 2, 0, and this point right here is 2, 0. Okay. And again, these are just rough sketches. I'm just trying to show you that just by knowing a little bit about hyperbolas and ellipse, it kind of helped me understand what's happening here in the intersections. Okay. And as you can see in this picture, that's exactly how everything went down. So we have the negative 2, 0, and this location right here, you can obviously see is 2, 0, and this location right here is negative 2, 0. So that's using substitution and elimination. Sometimes you might even get 4 answers. Like, what if our ellipse had done this? Then we would have had to find the 4, well, you get the idea. I can't draw an ellipse very well. We would have needed to find, and the answers would be very symmetric in that sense, because they would have to match, but the positive, negative versions of each other. But as you can see, it's kind of working how we thought it might. It's just you kind of have to think about what you're dealing with. I guess you could say the graph isn't necessary, but it's very helpful to know what you're getting yourself into. So when you find your answers, do the answers make sense? So here's 2 examples of elimination and substitution. Please let me know if you have any trouble. I tried to not make the homework too long, so it's just a little brief, maybe like 6 or 7 questions, okay? All right, you guys, thanks for watching. Have a good one.